All right, so today we are talking about radicals. We are starting today with radicals, starting the year with radicals. We are going to use radicals all year long, and so it's really important that you know how to simplify radicals and rationalize the denominator. So we are going to start with simplifying radicals. Before we start simplifying radicals, we're going to talk about perfect squares, because we're going to use perfect squares a lot when we are simplifying radicals. So what are perfect squares? So perfect squares are when a rational number, so let me just define this first and then I'll give you an example. So when a rational number is multiplied by itself. So that is our definition of perfect squares. So for example, an example of this is, say, 2 times itself. So 2 times 2 is 4. So 4 is the perfect square. Another way you can think of it is, can you take the square root of that number and it be a number you recognize? So we're going to list a whole bunch of these perfect squares that you need to know. You need to have them memorized, and they need to be pretty quickly memorized within your head. So for example, we can start with 2 squared still. So 2 squared is 4. Let me increase this really quick. So 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. And let's just stop there for now. You can go further than that, and we certainly will go further than that later on in the year, but that'll probably get us through today's lesson at least. So if we continue with our first example, example 1, square root of 75. So I'll show y'all how you probably are used to doing this, and then I'll try to show y'all how we're going to do this a little bit faster. So 75, when you're thinking about this number, how you've probably seen this done before is you make a tree and you say, well, I know 75 is divisible by 25. I'm thinking about quarters. So it's 25 times 3, and 25 is 5 times 5. So when you can find a pair, you circle that pair, and it's that pair that comes out of the radical. So 5 comes out of the radical, left inside the radical is a 3. And so that's how perhaps you've learned how to do this in the past. What I'd like for us to be able to do is go a little bit faster than that and say, well, square root of 75 is how I'm thinking, or what this number originally is. So within 75, I know 75 is 25 times 3. So even though it's kind of the same thing to start with, I'm going to just skip this step right here in the center. I don't have to know that 25 is 5 times 5. If I simply can understand that 25 is what we call a perfect square, and the square root of 25 is 5, then that's going to come out of the radical. Since 3 is not a perfect square, it stays inside the radical as root 3. And so you can see it's just a little bit faster than how we've done this in the past. All right, so for example 2, we have 3 square roots of 98. So right now what maybe looks different, stands out to you, is the fact that there's this 3 on the outside of the radical. All that's going to do is multiply whatever else comes outside of the radical. But besides that, it's going to stay the same. So if you're wondering, 98, you're not really sure maybe what a perfect square is that goes inside of that, but you do know 98 is an even number, and so if that's all you can say to start with, then just start there. 98 is an even number, so even numbers are divisible by 2. 2 times what is 98? So I know 2 times 50 is 100. 98 is 2 less than that, so that must be 49. Again, this is a non-calculator section if I didn't say that earlier, so you should not be using your calculator right now. All right, so this is 2 times 49. Well, automatically, look at what just happened. 49 is a perfect square. And I know that the square root of 49 is 7. So I'm going to skip that step and just say, well, 7's going to come out of the radical. Don't forget, though, that 3 was already outside of the radical, so there is a 3 on the outside as well. Look at that. I'm going to multiply it. And left inside of the radical is that 2. So final answer is 21, square root of 2. Okay, so that is our final answer for example 2. All right, so let's keep going. Let's go up to example 3. So example 3 reads, let me just delete this stuff. 4 square roots of 18 times negative 3 square roots of 32. Now you could do this in a couple of different ways depending on how you see it, but considering this is non-calculator, I'm going to do individual pieces. So what I mean by that is I'm going to evaluate this, then I'm going to evaluate this, then I'm going to multiply together. Because I think that's going to be the easiest way for me to do it. So 4 square roots of 18. So I'm thinking about 18 right now. And 18 I know is 9 times 2. That's great because 9 is a perfect square. And because 9 is a perfect square, 3 comes out of that. So I have 4 times 3, and then the 2 is left inside the radical. So final answer there is 12 square root of 2. All right, so now I only did this piece. Now I got to do this piece. So negative 3 square roots of 32. So I'm looking at 32. Now, I know a lot of things are multiplied to 32, but think about what is the perfect square inside of 32. And I know that 16 divides 32. And 16 is a perfect square. So that's going to be 2 times 16. Remember, I'm choosing 16 because it is a perfect square, and it comes out of the square root to become a 4. So now I have negative 3 times 4, and 2 is left inside the radical to make negative 12 square roots of 2. All right, so I've simplified this to that, and this is that. Now I still have to multiply these two things. When you multiply, like things will multiply. So what that means is that the 12 will multiply the negative 12. The fact that it's negative does not change anything. It's just going to be a negative number. So that's negative 144. And the square root of 2 multiplies the square root of 2. So that's what I mean by like things. These guys are considered regular numbers. They multiply. These are radicals, so they will multiply. 2 times 2 is 4, so square root of 4. Now think about, you always want to think about, is this simplified? So hopefully you can remember that square root of 4 does simplify. We all know square root of 4 is 2. So now I have negative 144 times 2, which is a final answer of negative 288. Okay, so that's example 3. All right, so let's go on to example 4. So 4 square roots of 48 plus 5 square roots of 125 minus square root of 243. So once again, I am going to do these things individually, and then I will see what I can do with adding and subtracting them. Adding and subtracting radicals can only be done when you have common radicals. So I'll explain that in a little bit more detail in a little bit, but I'm looking for common radicals there. So 48 is, okay, so let's say you can't think of the perfect square that goes into 48. Maybe you can, and that's great. But if you can't, let's go about the process of saying, well, can I do this if I just cannot think of it? So I know 48 is once again an even number. So it divides by 2 at least. That much I know. So 2 times, and it's 24 is 48. So that's good. I mean, I've at least started, but the problem is that neither 2 nor 24 are perfect squares. So I have to keep going because I haven't found a perfect square here. So 24, let's just let's just continue with 2. So I have 2 and 12. Well, now how you probably are remembering back from Algebra 2 is you have all of a sudden found this pair, so you know that that's going to get to come out of the radical. But you can't stop there because 12 is not broken down all the way. So now we got to have, let's just continue with the 2. So 2 and 6. 6 isn't broken down, so let's break it down to 2 and 3. So you can see that this is a much longer process, but it does certainly work. I've got another pair here. So don't forget about the original 4 that's out. So this is the original 4 that's out. This made a pair that comes out. This made the other pair that comes out. And this 3 is left inside. So that makes a final answer of 4 times 2 times 2. So 4 times 2 is 8, times 2 is 16. So 16 square root of 3. Now, I say final answer. Of course, that's just this guy right here. That's all we've done. Let me just really quickly, before I keep going, show you the easier way to do this. And that was to say that 48, if you can think of 48, is 16 times 3. 16 is that perfect square. So we had the original 4 that's out. The square root of 16 is 4. And then the 3 stays in. And so that's the same thing that we got down here. So you can see how much faster this is than this longer process. So let's try to do that faster process. So 5 square roots of 125. So 125, when you're thinking about anything that ends in 25 is divisible by 25, so that's great because 25 is a perfect square. And y'all need to be able to think about how to do this multiplication in a way that fastens your time. So 125, well, 4 times 25 is 100, and it's 25 more than that. So now it's got to be 5 times 25. And keep in mind, I chose 25 because it's a perfect square. And so out of that, I have the square root of 25 is 5. I had the original 5. So that makes 5 times 5 square roots of 5. So this is a plus sign right here. So plus 25 square root of 5. Now last problem, or last part, minus square root of 243. I'm going to have to bring this all over. So square root of 243. Now this is one that even I can't really think of a perfect square that's in 243. Since this is an odd number, I'm going to hope that it's divisible by 3 rather than 2. So 3 divided by 243. We're going to do some old style division here. 3 goes into 24 8 times. Remainder 0, 3 is 1. So what that means is that 243 is 3 times 81, which is perfect because what is 81? It's a perfect square. So square root of 81 is 9. So we have 9 square roots of 3. All right, so what I've done is I have simplified this to this, this to this, this to this. Now what I said when we started this process is that like radicals will add and subtract. So I only have 2 like radicals. My 2 like radicals are the root 3 and the root 3. So what is 16 root 3 plus 16 root 3 minus 9 root 3? So if you have 16 roots of 3 and I take away 9 roots of 3, you have 7 roots of 3 left. And then this guy's hanging out all by himself, so he's just got to be added on, plus 25 square root of 5. This would be our final answer. All right, let's keep going. So I'm going to define something else. I'm going to define rationalizing the denominator. So rationalizing the denominator is when you, let me define that differently. The process in which you get rid of a radical in the denominator. So that is rationalizing the denominator. The process in which you get rid of a radical in the denominator. And so on the next page, we will go through that process. All right, so I'm going to go to the next page. So you will be expected to rationalize the denominator unless otherwise stated. So just assume to rationalize the denominator always. So example 5 reads 5 over square root of 72. So you could rationalize the denominator now, but it's probably a lot easier if you simplify then rationalize. Basically in all of math, not even just pre-cal, but all of math, you should always simplify first, then do a step. Simplify another step. Simplify another step. You want to simplify as much as you can in between all your steps because it generally makes it a lot easier. That's not always, but it'll make it a lot easier for the most part. So what I mean by that is before I show you this process of rationalizing the denominator, I'm going to take 72 and do what I was doing on that other page. So 72 is 9 is the perfect square. So it's 9 times 8. Now, I did this for a reason. Maybe some of you thought of a bigger perfect square, and that would have been so great if you had done that. But what just happened is, look at this number I chose, 8. 8 is not a prime number. More stuff divides 8, and so that's not good. I don't really want to choose 9 times 8, but if I had, I'd want to keep going because 8 is 4 times 2. Look at that. That's another perfect square. So from the 9, a 3 comes out, and from the 4, a 2 comes out. So a 3 comes out, and a 2 comes out, and then don't forget that this 2 is stuck by himself, square root of 2. So that's 6 square roots of 2. Now, like I said, maybe some of you were saying, well, 72, I should have just chosen 36 times 2. That would have been the best choice because 36 is the biggest perfect square, and the square root of 36 is 6. So I'm just kind of trying to show you all the different methods you can do here. But either way, however you went about this process, you should have gotten 6 square roots of 2 on the denominator. This is only on the denominator. So all of this work, and I still have 5 divided by 6 square root of 2. Now I'm going to show you rationalizing the denominator. So once again, rationalizing the denominator is the process in which you get rid of the denominator, get rid of the radical in the denominator. So the radical that's in the denominator right now is the square root of 2, of course. In the denominator, I see a square root of 2. You're not supposed to have radicals in the denominator. So the process that we're going to take is actually a pretty simple process. You just gotta kind of get used to it. It's weird at first, but it's a pretty simple process. So what we do is we take that thing that we do not like right here, and we multiply it top and bottom. So square root of 2 on top, square root of 2 on bottom. This is going to be called the magic number of 1, and that's what I call it at least, the magic number of 1, because anything over itself is 1. So I'm not really multiplying times anything. Anything multiplied times 1 is nothing. I mean, you haven't changed anything. I'm just doing this to give myself the ability to rationalize the denominator. So now I have 5 times, look at what we have here, 5 times the square root of 2. So 5 square root of 2 over, now look on the bottom, I have a 6 on the outside, and I have square root of 2 square root of 2. Well, square root of 2 times the square root of 2 is the square root of 4. But that's the whole purpose of doing that. What is the square root of 4? The square root of 4 is 2. So really all I've done is I've done 6 times 2, which is 12. So final answer is 5 square roots of 2 all over 12. This process gets a lot easier. You're not going to have to do all of these little steps in between each one. I'm just kind of trying to show y'all all these steps while we're first learning this. Alright, so I can go to example 6. I hope you've copied this down. Otherwise, you might want to pause right now because I'm about to erase all of this stuff right here. Alright, so let's start with example 6. So square root of 50 over square root of 8. Notice how I said that. Even though you see only one radical, I said square root of 50 over square root of 8. If that's how a lot of people would think of it that way instead, and that's perfectly fine if you want to think of it that way. I actually usually do because I know I have to do something with the top, something with the bottom. There's so many ways to go about this process though, actually, now that I'm thinking about it, because 50 over 8 simplifies, doesn't it? Because they're both even numbers, and so they both could be divided by 2. So you could do that first if you wanted to. I don't know what to do first. I mean, there's so many things. Let me show you a couple of ways. Let's do the way that maybe you were thinking, because we're following the same steps over and over. So 50 is 25 times 2. I'm choosing 25 because it's a perfect square, so out of the 25, a 5 comes out, and 2 is left in. 8 is 4 times 2, so square root of 4 is 2, and a root 2 is left in. Now notice I have root 2 over root 2. Anything over itself cancels. That goes away. And I'm left with a final answer of 5/2. Now some of you guys might have thought about the fraction first, and if you would have thought about the fraction first, that actually probably would have saved you a step, because 50 over 8, like I was saying earlier, these are both even numbers. 50 and 8 are both even numbers, so automatically you could have divided by 2 and gotten square root of 25 over 4. And if you go back and think of it as square root 25, square root 4, you can get back to 5/2 pretty easily. So I'm not going to show you that. If you follow that, you can do it that way as well. Alright, so I have square root of 8 over square root of 27. I'm going to run through this pretty quickly and then just do a couple of the now you try. So square root of 8 is 4 times 2. So that's 2 root 2. Square root of 27 is 9 times 3. So that's 3 root 3. What is it that you don't like? It's the root 3 here. So you're going to do root 3 over root 3. This is a good multiplication practice. So like things multiplied. 2 is on the outside. That's the only thing on top on the outside. So it's left on top, so 2. But then inside the radical, 2 and 3 multiplied to make root 6. Over. Now on the bottom, I have a 3 here. So if you want to go ahead and write that, you can. You could have skipped a step if you see it. Root 3 times root 3 makes root 9, which is the whole point, because the square root of 9 is just 3. So now I have this 3 times 3, which is 9. So 2 square roots of 6 over 9. Okay. All right. I'm going to skip A. I think you can do A on your own. B, I'll just do a first step for you, so maybe you can do that. Instead of thinking of square root of 98 like that, anytime I see fractions, I want to view the entire problem as a fraction. So I would start as 1/7 times square root of 98, and I'm just going to put it over 1. And then I have 1 over square root of 2. So now maybe you can see this would divide this, and you can simplify your process a great deal. So the same thing here, this is going to be kind of like what we did up here. If you can follow this, remember this, and think of it for that example C, that would greatly increase the productivity of that. And this is the end of 1.1.